All right, we're going to try number 5 on AP Prep number 7, and we're trying to write the function 2x over 1 plus x squared as a Taylor series. And if you notice there, that looks a whole lot like the geometric series 1 over 1 minus x. And so I think I'm going to be able to basically tweak it into being that. So remember, the geometric series, 1 over 1 minus x is equal to 1 plus x squared plus x cubed, and so on, all the way up to x to the n. So I'm noticing here, this is the same thing as if I was multiplying by 2x and I had 1 over 1 minus, because remember, it's got to be 1 over 1 minus some input, okay? So that negative x squared is replacing the x variable, and I'm going to have to multiply the whole thing by 2x in the end. Okay, so let's go ahead and do this. So we've got 1 plus the input, and I'm going to replace the x with a negative x squared, plus the input squared, and so we'll have a negative x squared squared, plus the input cubed, and it's going to be negative x squared cubed, okay? And then the whole thing is being multiplied by 2x. So this is continuing on out infinitely. Whole thing is being multiplied by 2x. So if we simplify this, we're going to get 2x times 1 is 2x. We're going to get 2x times negative x squared, which is going to be minus 2x to the third. We're going to get, that'll be an x to the fourth positive, it'll be plus 2x to the fifth, minus 2x to the seventh, and so on. So it looks like we're going to have alternating series here. We can do maybe negative 1 to the n times x to the, looks like maybe 2n plus 1. If you're starting out at 0, you get a 1, and then you get a 3, and so on. And, oh, the whole thing is being multiplied by 2, of course. So probably negative 1 to the n times 2 x to the 2n plus 1, something like that would be our general term. Okay, so I think we have that. Now, part 2 asks us if we evaluate the series at 1, does it converge to f of 1? Is this a convergent series? So if you substitute 1 in here, you're going to get 2 minus 2 plus 2 minus 2, and so on. And actually, I think it's a geometric series, and you could check it doesn't meet the geometric series requirement. Anyway, when you work this one out, it looks like we actually get an alternating series here, or an oscillating series, I guess is actually the term. It's going back and forth between 2 and negative 2. So no, this is never going to approach a sum, okay? It looks like we're actually just multiplying by negative 1 each time, which is not going to work. So that would be part B. All right, moving on to part C. Let's see what we're supposed to do here in part C. Oh, this is really cool. So what they tell us now is, where did they get this function? This function is actually the derivative of the natural log of 1 plus x squared, okay? And we can actually use this to write the Taylor series for the ln of 1 plus x squared, because we now know that this series is 2x minus 2x cubed plus 2x to the fifth minus 2x to the seventh, and so on. So we know this is the derivative of that natural log function. If this is the derivative, we can take the integral of this function here, and the integral would be equal to the ln of 1 plus x squared. Isn't that cool? So the ln of 1 plus x squared would be equal to the integral of this whole thing with respect to x. Okay, so let's integrate. Raise the power by 1, divide by the new power. Looks like we get an x squared. Raise the power by 1, divide by the new power. Is that minus x to the fourth over 2, or 1/2 x to the fourth? Raise the power by 1, divide by the new power. Looks like we're going to get x to the sixth over 3. I think we'll get minus x to the eighth over 4, and so on. So apparently that's our series representation. That's really cool, because again, I don't know how to integrate that because the inside function has that x squared in it, but if you write it as a series, it's very easy to integrate because you can use the power rule. Very cool. Let's see, first 4 terms, and they don't ask us for a general term there. Okay, so that's what we need there. And then part D, Now, in 2020, you don't need Part D. In other years, you probably do. The previous series was an alternating series. Remember, the error for your alternating series is always going to be one value past wherever you cut off your series. So just look at this real quick. This is kind of tricky, actually. Notice they're asking for ln of 5/4. And on the surface, you say ln of 5/4. What does that have to do with anything? Well, 5/4 is 1.25. That's the natural log of 1 plus 1/4. Okay, if you go back and look at the equation here, we want the x value. So x squared needs to be 1/4. So that means our x input here would be 1/2. Okay, so what we're really trying to do is we're trying to put 1/2. If we sub in 1/2 here, it would be ln of 5/4. We're putting in 1/2. We need to know how many terms can we go out to get something that has an error, okay, the difference between some value of the function and the actual value of the ln of 54. We want the error to be less than 1/100th. So you really can just go out here and figure out where could I substitute in 1/2 and get something that's less than 1/100th. Okay, if you put 1/2 in here, you're going to get something that's bigger than 1/100th. I think if you put 1/2 in here, let's try this. 1/2 to the 6th divided by 3, that would be 1/64 times a third, which would be, that's going to be 1/192, and 1/192 is less than 1/100th. So what that tells me is that's small enough error that would be our first value we leave out, and we could evaluate the series with those first two terms, and then our first omitted value is the error. So 1/2 squared is 1/4, and then 1/2 to the 4th is 1/16 divided by 2 is 1/32. So it'd be 1/4 minus 1/32, and let's see. 1/4 would be 8/32, maybe 7/32. And oh, what the heck? We got a little bit of time here. Let's go ahead and take a look at the answer key and see how this thing was scored. So anyway, you can see here they set it up a little bit differently, but they end up with the same answer here. I think in the end we get 3 points for Part A. And they didn't say a whole lot on Part B. That's kind of interesting. Part C, they went through there, and we're already up to a decent number of points. And then the error was, unfortunately, 3 points there. But they do get that 7/32. So anyway, again, 2020, you only need the first 3 parts here, but the error is there for other years that might see this video.